Hello everyone and welcome to today's webinar, Changes to the New South Wales Advanced and Extension Syllabuses with Dr. Brian Dorofeyev and William MacArthur. My name is Caroline Poole and I am the New South Wales Sales Manager here in Sydney. Before we get started, in the spirit of reconciliation, Cambridge University Press and Assessment acknowledges the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respect to elders, past and present, and extend that respect to all Aboriginal and Torres Strait Islander people here today. Our presenters today, Brian and William, will be discussing the changes coming for the New South Wales Stage 6 Advanced and Extension syllabuses. Dr. Brian Dorofeyev and William MacArthur have extensive experience teaching maths in New South Wales schools and in HSC marking. Brian has also been on the HSC Mathematics Examination Committee and is currently Subject Master at Sydney Grammar School. William, also currently teaching at Sydney Grammar School, has been involved with the New South Wales Stage 6 Mathematics Curriculum Review. Straight after today's presentation, we will be joined by Ben Staker, our maths publisher, for a Q&A session. And following that, we will be showing some further information on the new editions of Cambridge Maths New South Wales Stage 6 resources. So with that, I will hand over to Brian and William to get started. Thank you.
Okay, so I'm going to be talking about the Maths Advanced and the Extension 1 syllabuses. I will start off with Maths Advanced, so next slide, please. Next slide. So I'm going to start off with a very superficial comparison between the new syllabus and the current syllabus. If you look at just the word count of the current syllabus, it's about 5,900 compared to the word count of the new syllabus, which is a bit over 10,000. And before we panic and decide that there's all this new content that we have to teach, it's worth pointing out that the reason for that is largely due to the fact that they've split content points and added a lot of detail. In the vast majority of cases, though, what was previously assumed to be content is now explicitly written. So with that in mind, if I were to go through and scrutinize every extra comma and extra word, we'd be here all night. So I just wanted to quickly go over what I'm actually covering tonight. Any scenario where content differs from the assumptions that the authors made about the current syllabus, I'll mention that. Obviously, any new content or any content that's been removed, I'll mention that as well. And anytime an idea has changed a course, either from year 11 to year 12 or between Advanced Extension 1 and Extension 2. What I'm not going to talk about are the vast majority of situations where what has assumed to be content is actually now content, and that's been addressed in the textbook. Unless there is a situation where there was a bit of debate around the matter and maybe some resources out there don't cover what those assumptions were. Also, if something has moved from one course to the same course, for example, a different part of Year 11 Advanced to a new part of Year 11 Advanced, I'm not going to bring it up here. Next slide, please. On the right-hand side of this slide, you can see a screenshot of what the current syllabus looks like. And on the left is pretty much what I've produced, and just a bit of an outline of what this presentation is going to look like. The round dot points represent the focus areas, which are the main headings in the syllabus, and the open circle dot points are the content headings. And you can see in the pink box there, if there's a plus, it means there's some kind of new material. A minus is something's been removed, and a square point just means a general comment that I'm making. Next slide, please. So this shows the current syllabus on the left and the new syllabus on the right. And I've got this here just as a brief comparison between the two main structures. And just to wrap our head around a bit of the language, with the current syllabus, we have broad topics and then we have subtopics within those. But with the new syllabus, the broad topics are called the areas of study, and the focus areas are the kind of smaller headings within those. But what you'll notice about the structure of the new syllabuses is they're actually presented in order of focus area, if you like, not necessarily area of study. And I'll be going through the new syllabus in the order that it's presented here. Next slide, please. All right. So getting into it, Year 11 Advanced, with working with functions under algebraic techniques, new content is specific use of the word conjugate in the context of rationalizing denominators. Also the role of discriminants in solving quadratics. So the current syllabus only mentions the role of the discriminant in looking at the graph of a quadratic, how many times it cuts the x-intercept, but now we're talking about conditions for roots to be equal, distinct, real, and rational. And distinct and rational are probably edge cases that may not have ordinarily been covered. Moving on to introduction to functions and relations. The language of one-to-one, many-to-one, one-to-many, many-to-many to classify relations, that is now gone. That's not a part of the advanced syllabus. And I have put a plus here just talking about a slight change in the language. A lot of the language, and this is more than just one content point, but throughout the syllabus, we're referring to a function as f and the output of that function as f of x. Moving down to quadratic and cubic functions, quadratic inequalities are now specifically in Year 11 Advanced. That's moved from Year 12, and that actually was in Year 11 Extension 1 as well. So it's good that it's kind of moved into Year 11 Advanced. Moving down to the content point, constructing and using functions, that I've brought this up just because it sounds a little bit confusing, but that is really just a content point talking about modeling problems with the previous ideas and the previous functions that have been addressed. Under direct and inverse variation, I've got here models of the form y equals kx to the n as new content, and models of the form y equals k over x to the n for inverse variation. With the current syllabus, they're really just addressed as, y is directly proportional to x, but now we've got things like y is directly proportional to the square of x or the cube of x, and that's the subtle difference there. I just wanted to say these slides are going to be produced and sent out to everyone. So I will be going through this stuff pretty quickly, and probably just keep that in mind if you feel like I'm going a little bit too quickly here. Next slide, please. So under working with functions, property of functions, relations, and graphs, finding the domain and range of composite functions, that's been removed. But I think that kind of still fits in with other material anyway, because you can't actually do that unless you know what the functions are. Moving on to piecewise defined functions, testing for piecewise functions even or odd, that's new material. And there's been an adjustment to the way that we discuss continuity. We're talking about continuity at a point rather than talking about a continuous function, which can be a bit of a landmine in a high school context. So most of these conversations really should be focused on the behavior of something at a point rather than over a domain. Moving on to trigonometry, trigonometry with acute angles, problems in 3 dimensions, that's now specifically in Extension 1. That's no longer in Advanced. Next slide, please. So under Introduction to Differentiation, speed is now in the syllabus. Speed was actually never in the current syllabus. Velocity time graphs have been removed. Distance time graphs are still in there. Under finding the derivative using differentiation by first principles, it's now limited specifically to quadratic functions. So the current syllabus mentions simple polynomials up to and including degree 3, but now we're just looking at quadratics. Acceleration as a second derivative is now specifically in Year 12. And I mentioned before the idea of continuity, talking about what's happening at a point. It's the same idea when we're talking about increasing, decreasing, and stationary, rather than talking about an increasing function or a decreasing function. Again, that's a bit of a landmine if you talk about real world, and definitions and what someone is likely to see at university. So now we're really just limiting that conversation to what happens at a point rather than over an interval. Identifying families of curve with the same derivative function, that's been removed as well. Under rates of change, that's where we're talking about displacement and distance. There's a specific dot point that mentions distinguishing between those two, which makes sense if you're going to talk about velocity and speed as well. The notation dx dt and x dot, that is actually only in the current Extension 1 syllabus, but now that use of notation is specifically moved to Advanced. Next slide, please. Under exponential log functions, the only thing we're differentiating is e to the x. So at the moment, we also differentiate e to the ax, but as you know, you need the chain rule for that. And any kind of use of the chain rule with differentiating exponentials is completely moved to Year 12 now. For exponentials and logs, modeling problems have been moved to Year 12. So all those problems about exponential growth and decay and, decibels and the Richter scale and things like that are no longer part of Year 11. I've got here an edition of equations involving logarithms, and that was kind of always in the syllabus, but what's interesting is the example in the syllabus. If you look at the example here, it's maybe a bit harder than we may have previously expected. If you go ahead and solve that, I think you end up getting x is 8 and -1. And then obviously you need to consider the domain of the left-hand side and then exclude the -1. So I brought that up just because it's maybe a little bit more gritty than we may have previously thought. Moving on to graph transformations, translations, dilations, and problems involving multiple transformations, that has all moved from Year 12 to Year 11. So it's worth pointing out that now accompanies the work on reflecting about the X and Y axis. So that's all now in one spot in Year 11. The exception to that is that all transformations of trig functions are specifically in Year 12. Next slide, please. Under probability and data, there's a much more formal treatment of sets in the syllabus now compared to what's in the current syllabus, but that is actually in line with the treatment of the current textbook. Those that use the Cambridge book will know that there's probably a bit more formal of a treatment of sets in the textbook. Under conditional probability, they've added a few contexts to talk about conditional probability, namely Venn diagrams, two-way tables, and tree diagrams. The current syllabus only mentions really the formula and just the general idea, but this is just outlining a few different more extra contexts that can pop up. Under data, I've got here discrete random variables and continuous random variables, just the concept and terminology. So students need to be able to define these things and talk about them, do things like relative frequency and find the mode and median and things like that. But it's really a focus on the distributions and showing the distributions rather than studying the distributions, if that makes sense. And one of the big changes of Year 11 Advanced is that discrete probability distributions is now being moved to Year 12. Next slide, please. So that's it for Year 11 Advanced. For Year 12 Advanced, again, on the left, we've got the current syllabus. On the right, we've got the new syllabus. The two major structural changes would be sequences and series being a standalone topic in Year 12 Advanced. And also, you'll notice under calculus, we've no longer got applications of differentiation, but we've got applications of calculus, which now comes after integral calculus. So it's perhaps a bit more broad. I don't think that really leads to any major changes, but it does make sense from a structuring perspective. So jumping into the Year 12 Advanced syllabus, next slide, please. So as I mentioned, the exponential and log modeling problems, they have now moved to Year 12, and this is where they pop up in the further graph transformations and modeling section. Under sequences and series, most of it is pretty much what we would have expected it to be. The main thing that stands out is the specific use of sigma notation. So that was kind of, a little bit controversial in some places, whether or not you could use sigma notation, but it does actually pop up in sequences and series now and can be used in other contexts as well because of that. Next slide, please. So as I mentioned earlier, we're now differentiating e to the ax in Year 11. And this topic really is just getting through all of those derivatives of logs, trig functions. And again, this dot point at the end here, using derivatives. If you look at the actual syllabus, that's really just about applying all the product rule, chain rule, quotient rule to all these functions and all your typical problems on tangents and normals and things like that, but not actually the applications of calculus, which comes later on. Next slide, please. Probably the main thing to mention here is the way that language is used, and it's a lot more formal in the new syllabus than it is in the current one. So I mentioned before the inclusion of sigma notation. So if you have a look, this is a direct quote from the syllabus. Consider the definite integral as the integral from a to b of f of x dx as the limit. And we've got, this idea of moving from a discrete to a continuous kind of idea there, which obviously is fleshed out much later on when you're talking about discrete and continuous probability distributions as well. Jumping down to the bottom, area between a curve and a y-axis is now explicitly in the advanced syllabus. The current syllabus only mentions area under a curve, which, a sensible inclusion might think that that's just between a curve and the x-axis, but now we're including the y-axis as well. That's actually already in the Cambridge text. And the area between two curves, that is now explicitly extension 1 content. So that was actually an area of overlap between advanced and extension 1. That was in the current syllabus, it's mentioned in both. Now it's specifically in extension 1. Next slide, please. Differentiability comes under applications of calculus, and tying in with the idea of continuity, increasing, decreasing, stationary, everything is talking about what happens at a point, and the same here is differentiability. So the main kind of context, you're probably looking at piecewise functions for that, and just determining if it's differentiable at a particular point. Under rates of change, as I mentioned, acceleration has moved from year 11, including that notation, d squared x over dt squared and x double dot, which was actually only previously in extension 1, but now it's in advanced as well. Under random variables, discrete random variables has been moved from year 11, that's now in year 12. And under continuous random variables, is explicit inclusion of calculating the mean and the variance in a continuous distribution. That's already in the Cambridge textbook though. Under normal distribution, we've got the notation denoting x as a normal random variable. That's already used in the textbook, but it is actually new to the syllabus. And one of the most significant changes of the year 12 advanced syllabus, you'll see here, is the removal of Pareto charts, parallel box plots, using quartiles to determine outliers, and bivariate data analysis. So that's all of the scatter plots, Pearson's correlation, least squares, etc., which, if you're familiar with the current syllabus, you'll notice all of these things have a common theme, and that's that they're all common content with Maths Standard. So common content has been removed, and I mean common content in the proper noun sense. There are still some concepts that are in both courses, but there's no explicit effort to include common content between the courses, if that makes sense. Next slide, please. And finally, I've got financial mathematics, and again, touching on that idea of common content being removed. Business as usual here, except for the removal of financial tables, which I know a lot of advanced students will be pretty pleased about. All right, next slide, please. Okay, this slide's kind of scary, and to be honest, it's not particularly useful, but I did just want to mention on the left-hand side, we've got the syllabus, and on the right-hand side, we've got the chapters in the Year 11 advanced textbook. And the reason I've put this slide together is I just wanted to mention that the order of the syllabus is perhaps not necessarily the ideal order that you would want to teach the topics. And the authors have put together for a long time, have thought about this a lot, about the ideal way to present these ideas. And there is a curriculum grid that's been produced. So this isn't your curriculum grid, so to speak. But I just wanted to mention that the order of the syllabus doesn't necessarily match up with the order of the textbook. As an example, if you look at the third last topic on exponential and log functions in the syllabus, that maps to chapter 3, function and graphs, chapter 8, exponential and log functions, and chapter 10, Euler's number. And if you think about it, that actually makes perfect sense. On chapter 3, we're revisiting things like y equals 2 to the x and y equals 2 to the negative x, making sure people can graph basic exponentials. In chapter 8, we're doing all of the ideas of shifting, translation of those functions, as well as introducing log functions. And then obviously in chapter 10, that's when we've got the basic ideas of calculus under our belt, and we're looking at it from a whole new perspective now. So it does actually make sense to split up those ideas in that way. All right, I'll hand over to Brian now to talk about how the advanced syllabus has been implemented into the textbooks.
So I thought I'd take a step back to start with and look at the course holistically in the large, so to speak. And I guess right from many years ago, these courses, the extension advanced courses, teachers spoke of them as the calculus courses, and that's continued to be the central aspect, I suppose, of these courses. And even the current syllabus, advanced syllabus, talks there about the concepts and techniques of differential and integral calculus are the basis of these courses. So that is very much central to teaching these courses. But at the same time, you could also consider an exploration of the basic functions of mathematics, and the syllabus uses that term, the basic functions of the course, the lines, the parabolas, the polynomials, the rational functions, trig and exponential functions, and of course other ones like hyperbolas and circles that we explore. And so calculus becomes a tool to explore these functions further. But these functions are also a playground, if you like, to explore calculus as we apply them. Graphing becomes and still is central to the course because that ties together the calculus and the basic functions. Graphing enables you to look at these functions holistically, and so a student hearing the word parabola should immediately think, what does a parabola look like, and have a picture in their mind of a parabola, and then the calculus comes in and you talk about where the tangent's horizontal and they think, oh, I know what that means. And you talk about concave up and they know what that means. So very much as teachers, we're trying to tie the concept of graphs to give a holistic view of the graphs and to tie that to calculus and what it means in that context. So a student coming to the course and wanting to make a success of it can't just know the algebra of the functions, they need to know what the functions look like, how they behave, understand them in a holistic way. We're certainly quite familiar that applications is a very important concept in the modern world and in the modern syllabus. And we see that the basic functions in the calculus and, of course, the sequences form a foundation, a brickwork, if you will, that the applications are there built on. But if those foundations aren't there, then a student is not going to be very successful at these courses. And as we go through how the textbook authors have implemented the Cambridge textbooks, you'll see that we've always tried to get the basic foundation strong so the student can then start building the applications and so on top of that. Because if they don't have those, then the rest of it is going to be a mess. Statistics, of course, comes in there as well, and straddles, perhaps obviously it calls on calculus, and there's plenty of graphs and statistics, but applications, very much about applications, and probability, if you like, is part of that picture as well. Next slide, please. So if you're sitting down to teach a course, or to write a textbook about a course, of course, you need to have a clear philosophy about the subject and about teaching the subject, what we might call the philosophy of mathematics and the philosophy of mathematics education. And mathematics, of course, is about patterns, it's about proof, it's about exploration and understanding. And we can't do maths without skills, and skills and understanding are built by practice. Targeted drill is important. And every time we sit down, of course, as teachers and write a new assessment, then we have those central ideas and our two components that we include in every assessment that students need to understand, and therefore we need to teach them to understand, and students need to have skills that they can apply their understanding to as they explore the basic functions, the calculus, the ideas that we're presenting. So our philosophy as teachers and also as textbook writers is to teach students to understand and teach students to apply skills that model their understanding and further their understanding. Next slide, please. So how do the Cambridge textbooks try to implement the new syllabus? Well, obviously, key is covering the syllabus, and we have tried to be faithful to the syllabus. We cover all the dot points, and you'll see that I've reproduced the slide there that William had, linking all of those new syllabus content areas to the textbook chapters. The current text occasionally had to make judgments. That's the 2017 syllabus. Had to make judgments about material to include where occasionally the syllabus was unclear, and that led to longer textbooks than otherwise we might have liked. But the new syllabus has tightened up most of these areas. In fact, Billy talked about the fact that the new syllabus is 70% longer the advanced syllabus than the previous one, and that's not because of new content, it's because they've made various areas clear, they've made various inclusions obvious, whereas before as textbook writers we had to and ah and say, oh, I've in doubt, let's put it in. But we haven't got that issue to the same extent this time round, so the textbook is more closely follows the syllabus than the current textbook has, just because of that reason. We have tried to be very faithful to it, and occasionally we've even taken out some of our favourite topics. Special quadrilaterals used to be a little bit there in the coordinate geometry, but we took the view that the whole point of that coordinate geometry chapter, which we've renamed as coordinate graphs in the number plane there somewhere, is about tangents, about getting to understand how tangents work and picturing them with the graphs. So we have taken that out of the advanced syllabus and the advanced book, except for a mention in applications. Next slide, please. Obviously, in mathematics, clear explanation is important. We're trying to train the students to explain clearly. It's not about understanding, it's also about understanding and explaining your understanding, about explaining to somebody else, about communication. And so clear communication from a student has to be modeled by clear communication by a teacher and, of course, by a textbook. You as a teacher wouldn't want to direct a student to a textbook or put up an example on the screen and then be embarrassed that clearly the communication is good, the use of language is bad. That is not something that you'd want them to be looking at and modelling. So we've tried to make examples clear. We've tried to make good use of language. We've tried to use mathematical language correctly. So we've sat around and argued for hours about what the correct mathematical terms are, how they should be used, how they're used formally by mathematicians. Now, clear examples in text obviously provide examples for students for setting out their work. So looking at that example on the right, a student can look at that and say, that's what you want. You want a clear explanation of the chain rule, you want some working on the side, you want to get down and get the answer, and your answer wants to be clear. You want to have proper mathematical sentences and good use of words where appropriate. So these examples model good mathematics, and they support good teaching for the teachers. And these can be used confidently by teachers as a reliable source of examples, and they can be a good introduction to new teachers wanting to look and say, how should I be teaching this? What should I be doing? How should I be explaining it? Now, it's also true, of course, that clear explanations and so on is an important thing, and even in the modern HSC, where questions about discuss and explain, it's not enough for a student to be able to do a chain rule or to find an answer. They need to perhaps unpack that and explain what they found and the significance. So we have tried to include examples, modelling the whole idea of examples, of explanation and telling people what you're doing. Next slide, please. Now, textbook hopefully will have features to aid the learning journey, either by the teacher as they teach their class or the student as well as they read the textbook in their free time in the evenings. So there's a few new features that we see in the textbook, or some features that are just favourites that have occurred. We've added learning intentions at the top here, just like you might at the start of a lesson. If you've been well trained through Teachers College, you start your lesson plan with a learning intention. What do I want students to take away from this? What do I want to teach so that I can target my teaching? So every exercise, every section of the textbook starts with a learning intention, saying this is what you want to take away because this is central to this aspect of the syllabus in this particular chapter and section. Also, a consistent narrative through the chapter, because students learn best if they understand. They learn best if they understand it in context, if they see how the first idea connects with the second, that connects with the third, and they can build a whole narrative story from that helps them connect the ideas, helps them learn the ideas, helps them recall and retain the ideas. So that's an important thing that's always been there in the Cambridge textbooks. And obviously, of course, the very famous and favourite summary boxes, numbered summary boxes, so that students can use that for the learning and revision. So you can say, students, I know you're looking a bit glazed-eyed, have a look at box 8, take away what's there. Remember this, even if you don't remember anything else. Next slide, please. It's very much part of the philosophy that we're talking about, that the bricks and mortar are those foundations. And so the textbooks very, very much start with the foundations. Unapologetically, we don't start with something really complicated. We start with a review of the algebra, of the surds, of the functions and graphs. I hasten to add this is all syllabus material. The students need it. But while you're thinking about programming, you're making your scope and sequences, your programs for your next year and the year after, you might want to think about, is there some of this material that you can prune in order to get through the syllabus? And that obviously depend on your students. Some students need to strengthen their foundations. They come in with weak algebra. They come in with weak work on surds. Maybe they've come through the PARs or haven't come through the PARs, and you've pruned that a little bit in year 10. Then some of this work in the first 3 or 4 chapters you'll need to spend more time with, but that depends on your case, your use case. I point out there are a few concepts here that you don't want to overlook that probably are new. For example, in 2A is where we've slotted the interval notation, and function notation may be new if you haven't met that in year 10. So I would definitely teach that, definitely lay good foundations, definitely assess it, but I would be happy if you had strong students to move through that pretty quickly. Next slide, please. So as I said, it's very important as teachers to build foundations before you move forward. And that's why unapologetically, we start with a review of basic functions and graphs. It's why also, as William has mentioned, the trigonometry is given a thorough review before we, for example, introduce radians in a separate chapter. It's required in year 11, and therefore we include it in year 11. But we're quite keen that students understand about trigonometry. They can handle angles of any magnitude. They can solve a basic trig equation in degrees before we start throwing radians at them. So foundations is important, but then you move on to the radians. Equally, exponential and log functions, we give them a thorough review because we believe that indices and logs are a weak point for students. We want them to understand that before you throw Euler's number in a separate chapter. So you can see the chapters there, how down the beginning of the chapters, the beginning of the textbook, nailed those foundations, we've got them strong. When your students are ready, you can move on. Next slide, please. It's one of the things that is always comforting. People tell me about the grammar textbooks, not the grammar textbook, I should say, the Cambridge textbooks, so many grammar authors involved. The Cambridge textbooks is that they're very weighty, the very sort of thing that you want to have in hand if you meet somebody in a dark alley who looks a bit suspect. But also, they have a lot of exercises in the exercise, for example, here in exercise 9D. And so I just want to take a little bit of time to explain how you should be using these. And apologies to the old timers who have used these for many years. So obviously, we believe that students need plenty of drill to understand and internalize concepts. And we all know the common refrain about 10,000 hours of practice to become an expert. Unfortunately, we don't have 10,000 hours, but as much drill as students can possibly fit in will just make them stronger at the ideas. The drill will help them to consolidate, to understand, to reflect, and to have applications drilled into them. So every exercise is divided into foundation, into develop, and into enrichment. Students are not expected to do all the exercises. Let me say that again. Students are not expected to do every single question. Okay. Teachers can assign exercises appropriate to the class or the student. Of course, that's differentiated learning that we know is so important. But all the exercises are carefully graded. So that whiplash effect where, you tell students they do 1, but don't do 2 because that's hard. You do 3, but skip 4 completely and do 5, and then go to 10 and then come back to 8. None of that in the Cambridge textbooks. They are carefully graded. If you have a look at the foundation exercises there, that very first question, there are not many words. It's one step. Students can get confidence. They can pick the ideas up that you've just explained to them on the board, and they can do that easily. As they work through the foundation, they start to build confidence. And once they move into the development, they get questions that can be a couple of steps. Sometimes they have links with previous topics or previous chapters, but there's another step up for the students once they've made their way into the development. And then by the time they get to the challenge, as we call it in the advanced course, or enrichment as we call it in the extension, they're getting pretty strong, right? And some students won't get to the end of the development, they won't get to the challenge. That's fine. The whole point is to enable differentiated learning. Now, we're quite conscious as authors that there are many classes that you'll have a range of students there. You'll have those students who need plenty of time at the beginning of the foundation. They won't get far into the development. That's fine. That's where they're at. But always the challenges in front of them, because they can see the extent of the exercises. They can see just another question. I'll be halfway through the development, and you'll say you're laying that challenge before them all the time. Whereas other students, they won't spend long in the foundation. They're a genius that sits at the back of the room and obviously knows everything, and they want to spend a little bit of time in the foundation, get straight into the development, and then they won't be bored because they've got the challenge questions to keep them busy. Let me add that the challenge questions do include material that is in the HSC. It's not that we're putting stuff that's outside the syllabus, or if it is outside the syllabus, it's the type of question that's, it's peripheral. You could imagine an application within the syllabus or the material within the syllabus that puts a question together like you see in the challenge. Next slide, please. We very much believe that theory is important because mathematics is about proof, it's about understanding. It's not about black box learning, and we're not interested in a textbook which just tells people how to do things without understanding. Students who don't understand don't really know. They can't apply something outside context. They can't do the explain or discuss questions because they don't really know what's going on. So we very much, where possible, justify or prove results. But it is not a university course. We keep ideas concrete. We don't overdo abstraction. And theory is developed at the level appropriate for the students in the course. So let me notice here that the advanced and the extension books, for example, will handle the theory differently. I have an example here of differentiating x to the n, the famous formula, the derivative of x to the n is n, x to the n minus 1. In the advanced textbook, most students are going to be happy to think plenty of examples of first principles, understanding the ideas behind the proof. And then if they suddenly want something more challenging, you can refer them to the appendix where we've put the proof. The extension student, on the other hand, being a stronger student, we've included that within the text itself. And we've actually used some of the theory that they'll be developing later on for the binomial theorem. Different students, theory is appropriate to each student, and some students will do more of it than others. Next slide, please. Applications. I mentioned applications is an important emphasis in the new syllabus. I think we all know that. And as I said, philosophically, as authors, we believe it's important to build foundations first. Many of the applications are in the year 12 course, and so the syllabus also backs that idea that year 11, it's a chance to get your foundation strong so that you can then build on that in year 12. As teachers, we need to help students with mathematical literacy, interpreting wordy questions, and explain questions. So very often the best way, I believe, to teach students about applications is to have discussion exercises. So those longer exercises, if your students are not getting far in the development, that's fine. Take a lesson, take half a lesson, where as a group. You sit down and work through a couple of those questions, a couple which have a bit more explain or wordy questions to interpret, and you model how to do it, have discussion about it, and they get the idea of how to handle those sort of questions. But these explain questions are increasingly being seen in the HSC, and there are plenty of examples there in the textbook that you can get students to do, that you can model in many different ways. Next slide, please. I threw this slide in because we're all sort of familiar with the change in the HSC exams over the last few years. For a bit of nostalgia purposes, I put a 2013 long question there. This is the first long question, so this is after multiple choice was introduced. But you can see question 11 there in the 2013. It's not very wordy. You know what you're doing. It says do this. It says do this. It says do this. Students know what they're doing and they can just settle themselves down working through it. Whereas the modern HSC, the very first long question could have an interpret, it could have a context to read, it could have something that they've got to unpack, not just apply a skill. So students have to be better than they once were at unpacking strange contexts and understanding and explaining. On the right, I've given some recent HSC style exams. They're not all early questions, but question 12 is fairly early. And it's not the whole question. These are just some of the stems, but there's a context they have to read, they have to understand, they have to digest. And question 27, 26 there remind you of questions where there's a diagram, there's an application, there's a model, all these sort of questions. You need a textbook that will give you plenty of these examples, give you the understanding of mathematical literacy, give you plenty of chance to challenge yourself with these. Next slide, please. Two big syllabus changes that I won't say much about because William's already alluded to at least the first of these. There's no reference to common content in the new syllabus documents. And that is just what's fairer to advanced students who didn't spend much time on that content. But also it does mean the content, there's less content and the syllabus is less overfull. So that's a good thing when you're programming your new, putting new programs together. Alternative assessments are optional, which reduces the stress on pupils, and even better, the burden on teachers writing and marking alternative assessments. But I hasten to add aspects like technology and applications that often seen as the domain of alternative assessments is still in there, and you might want to think about how you're meeting those requirements. But your assessments can be more tailored to the HSC style. Next slide, please. Changes to sequencing in the new textbooks. You will be familiar with some of this from what William has talked about. But the advanced textbook is about the same length as before, even a shade shorter. There are a few changes that have been made to improve the organisation of material to shorten chapters. Equations and equations becomes its own chapter, so watch that when you're programming. There's the name change I alluded to, lines in the coordinate plane, reflecting the new emphasis in the syllabus, and extending calculus is split up. Probability distributions is in year 12, and data and probability ready students for statistics later. So that's a welcome change. But by and large, the order of topics is much the same as you'll be used to teaching at the moment. Next slide, please. And that's from me.
Okay, thank you, Brian. I'll step in here. So, hello, everybody. My name is Ben Staker, and I'm a math publisher here at Cambridge who is working with the Stage 6 authors on these resources. I thought this, before passing back to William and Brian to talk about Extension 1, I thought I'd just jump in and talk a bit about some of the digital updates for the interactive textbook and online teaching suite. Next slide, please. So, as Brian has talked to in his presentation on the print book, a big focus of this new edition is increasing support for teachers as well as students of all ability levels. You can see this in the print book with the addition of learning intentions, which break down the core skills needed for the syllabus and map those to the actual sections of the textbook. And so just as in years 7 to 10, something that we're adding with this new edition will be the skill checklist for every chapter. So this will be online and downloadable. It will list all the learning intentions in the student active voice and can be used by students to try and track their progress and attainment as they work through the sections of the textbook, as well as the syllabus. A little bit different to the 7 and 10 books. So this skill checklist will link to sections on the text that students can go read and reference. It will link to examples that go through those core skills that the learning intentions outline. They'll have a video for every single example. So if a student's kind of stuck on an idea, they can work through the example. They can watch the video to get a better understanding. And then additional, for practice as well as testing themselves, there's also a link to a question in the new foundation level skill sheets that we're also introducing. So this is another new feature. So these skill sheets are sets of questions for every single chapter, broken down by learning intention. So for every single learning intention, there'll be 1 to 3 questions that students can go to and test their understanding of the learning intentions, the core skills from the syllabus, work through these problems. If they're a high achieving student, this could just be a test to check that box, or if they're kind of struggling, these are additional questions outside of the textbook that a student could use to bridge that gap between text and theory and the exercises themselves. So if they're struggling with exercises, they're not, they can't really do the development questions and they need more foundation questions, you can send them here and they can practice these skills and really drill them down, specialized to each learning intention. Next slide, please. In addition, for additional practice, this is another feature from the 7 and 10 book. So we'll have quick quizzes for every single section. So this is 5 additional foundation level multiple choice questions within the digital interactive textbook. These are auto marked, so students can get immediate feedback. They can also be set by you using a task directive, or printed and handed physically to the students. And the aim of these is just giving students even more practice at that foundation level. We'll also be updating the instructional videos for every single example. That includes Extension 2 this time around. So Extension 2 will also have instructional videos for every single example. We'll be improving the work solutions for every question to help students work through them if they're stuck, outlining some of the thinking behind each step. And then we'll also be updating the auto-marked multiple choice review at the end of each chapter. So this is 10 additional questions to practice for those more HSC style questions. And this will also be printable. Next slide, please. In addition to that, we'll also be updating the end of chapter review activities that are in the current edition. So first of all, we're going to have printable chapter summaries. So as Brian was talking about, one of the key features in the textbook is those key summary boxes that are scattered throughout. To make reference of those a bit easier for when it comes to revision time, we've collated all those the learning intentions into a single printable PDF document that you can print off and give your students, or they can access. In addition, to complement this, we also have updated review activities. So these will be very similar to the summary, but also include the examples. And then what we've done is we've removed all of the text from the example, except for the question. We removed the body from the summary boxes, and then given enough space so students can take those and add in those summaries using their own words, work through the examples using their own logic and laying out, and then they can then check back into the textbook to kind of see how they're doing, so they can use their active recall when they're working on their revision. There'll also be an accompanying PowerPoint so that you could do this as a classwork, throw it up on the projector and go through this as a class. Then finally, we'll also have new updated chapter tests that contain multiple choice and written response questions this time around. So in the last edition, there were just a long list of additional review questions. This time, they're a bit more refined. You'll have 5 to 10 multiple choice questions, as well as 3 to 5 written response questions that you could use as assessment or assessment practice. And you have 2 of those for every single chapter, only accessible to the teacher, so that you can choose when you want to share those with students. So that pretty much summarizes a lot of the main changes that are happening to the online digital for the interactive and the online teaching suite this time around. So now I'll pass back to William to talk about the changes to the Extension 1 syllabus. Thank you.
Okay, next slide, please. Okay, so this is a quick overview of the Extension 1 syllabus. I've got the Year 11 current syllabus on the left here and the new Year 11 Extension 1 syllabus on the right. The main structural change you'll notice is that there's actually no calculus in Year 11 Extension 1 now, and I'll talk a little bit more about that later on. Next slide. So under the further work with functions, there's quite a few ideas that have been removed. Sketching y equals the square root of f of x and y squared equals f of x, they've been removed from the new syllabus. Sketching absolute value of y equals f of x, that's actually not in the syllabus, in the current syllabus, I should say, but it did find its way into a supporting document, and that's why it's in the current textbook, but it is not in the new syllabus, so it will not be in the new textbook. Sketching the product of f of x and g of x, that is also removed. Under inverse functions, I mentioned earlier in the advanced syllabus that classifying relations using one-to-one, one-to-many, many-to-one, many-to-many has been removed. One-to-one is specifically Extension 1 content now in Year 11, and that's in the context of inverse functions, but that's the only classifying language that's used. Under inequalities, quadratic inequalities are now specifically in Year 11 Advanced, so technically that's removed from Year 11 Extension 1. Cubic inequalities for a factored cubic are in Extension 1 explicitly, but those of you that are familiar with the current syllabus know that a lot of those problems, inequalities with pronumerals on the denominator, require the student to be able to deal with a cubic inequality anyway, but it is good that that's now explicitly in there. Language and graphs of polynomials. Concepts relating to multiple roots and roots of multiplicity m are defined in Year 11, but the calculus techniques associated with that have been moved to Year 12. The rest of polynomials is pretty much the same though, so it's quite a tame Extension 1 topic. Next slide, please. As I mentioned, 3D trig problems were previously in advanced, but they're now explicitly in Extension 1. Under further trigonometric identities, T results are no longer in Extension 1 at all. Products to sums trig results are also no longer in Extension 1. Both of those have been moved to Extension 2, and they're under the topic of integration. So both of those results previously could have been pulled up in Extension 1, typically in solving trig equations, but that is no longer the case. Under further trigonometric equations, what's often called the auxiliary angle method, looking at expressions of the form a cos x plus b sin x, that's now in Year 11, Extension 1, moved from Year 12, Extension 1. And there's also a content point called modeling and solving practical problems using trig equations. So I would interpret that as just, maybe it's a changing tide or something like that. And it's just the context of a trig equation, so to speak. Inverse trig functions have been moved entirely from Year 11 Extension 1 to Year 12 Extension 1. Next slide, please. From permutations and combinations, pigeonhole principle has now been removed. So it's kind of, if you're familiar with the old pre-2017 syllabus, it's now similar to what it was back then. Under the binomial theorem, I wouldn't say there's been a lot of changes, but a lot more clarity has been added, which has, in a way, made it an easier topic to deal with, in the sense that the techniques for proving binomial identities are now quite clear in the syllabus. So substituting values, comparing coefficients, and applying combinatorial arguments, all of these are in the Cambridge textbook, and they are the techniques now that are specific and in the syllabus for proving identities. Using calculus is now explicitly excluded in the syllabus. They are in the current textbook, but it will be removed. So they're ones where you're differentiating an expression and then substituting into it afterwards. So they will be removed from the textbook. And as I mentioned, the main other notable change for Year 11 Extension 1 is that there is no calculus. So just quickly going through that, the rates of change with respect to time, that was actually already overlapped with advanced anyway, but that's now been removed. Exponential growth and decay, the standard model for growth and decay is overlapped with advanced. The modified model has now been moved to Year 12 Extension 1. And related rates of change, that has also been moved to Year 12 Extension 1. Next slide, please. So looking at the Year 12 Extension 1 syllabus, the main change is probably with vectors, but I'll get into that in a second. So next slide, please. So proof by mathematical induction, that's pretty much business as usual, but I will mention that sigma notation has now been added in advanced. So therefore, you could reasonably expect mathematical induction problems to be using sigma notation. And in fact, the example in the syllabus does use sigma notation. With introduction to vectors, all of the operations that we did with two-dimensional vectors, we're now doing with 3D vectors as well. So things like adding, subtracting, dot products, projections, things like that. But moving down the list there, applications of vectors specifically related to motion. So that word force you will not find in the Year 12 Extension 1 syllabus, meaning things like pulleys or those inclined planes with friction and things like that. They are not fair game in Extension 1 anymore. The other one from vectors that has moved is proving geometric results. That is now specific to Extension 2. Next slide, please. So as I mentioned, inverse trig functions were moved from Year 11 Extension 1. They're now in Year 12 Extension 1. Under the graphs, there are things like y equals sine of inverse sine of x, etc. All of these are in the current Cambridge textbook, but they have now been explicitly included in the syllabus. There's also mention of graphing transformations of trig functions. This is all explicitly in the Cambridge textbook already, but one thing now is that dilations is now part of Year 11 Advanced. And now because inverse trig functions are Year 12 Extension 1, the implication is that dilations are a part of Year 12 Extension 1 inverse trig functions as well, whereas previously, technically, they couldn't really do that. Moving on to further calculus skills, parametric differentiation is specifically included in this section. And I just wanted to make a comment here about the notation as well. The notation for the derivative of an inverse function, previously that just said dy dx is 1 on dx dy. Now it's written in a different form that I've got there. That's a direct kind of quote from the syllabus. I don't think the intention is that everyone uses that notation. My interpretation of that is that they just want students to be versatile in looking at the different types of notation that can be used for these things. Next slide, please. As I mentioned, multiple zeros using calculus techniques has moved from Year 11 Extension 1. That's now explicitly Year 12 Extension 1 content. And a lot of these ideas around calculus you will find here now rather than in Year 11 Extension 1. So related rates and also the modified exponential growth and decay problem. So things like Newton's law of cooling, that's now Year 12 Extension 1. And it kind of fits well, I think, when we're talking about differential equations and things like that in the same topics. Areas between curves, I mentioned earlier that was moved from advanced. That's now specifically Extension 1 content. Under differential equations, I don't think much has been added or removed here, but the language has certainly changed. Things like the order of a differential equation, initial value problems or an IVP. These are direct quotes from the syllabus. The syllabus now talks about slope fields. You will not find mention of a direction field in the syllabus. And there was this obscure content point in the current syllabus saying that students need to identify a first order linear differential equation, which is actually not trivial because the linear maybe isn't as obvious how that comes into a DE as you might think, but either way, that is actually removed. There's also a comment there that is good for people that are new to teaching the course, I would imagine, that solving the logistic DE cannot actually be done with Extension 1 technique, so they'd need to be given the partial fractions decomposition, which is actually Extension 2 technique, but they're just kind of given everything they need for the problem, and that's now explicit in the Extension 1 syllabus. Next slide, please. So there's some pretty significant changes with the stats in Year 12 Extension 1 as well. Just a quick one on notation in binomial distributions, just like with the normal distribution, saying that X is a binomial random variable and denoting it using that language. That's already in the Cambridge textbook, but it's now also in the syllabus. The central limit theorem, which will please many statisticians, I'm sure, that's now explicitly in Year 12 Extension 1. But the one removal from this topic is the normal approximation to a binomial. All right, next slide, please. So I'll now pass over to Brian to talk about the extension syllabus and how it's been implemented into the extension textbooks.
Okay, I shall keep this very, very brief. Sometimes there's confusion. I find pupils asking me whether they should buy both the advanced and the extension textbook. And the easy answer, of course, is they want to support my retirement fund. Absolutely, they should buy both textbooks. But the real answer is that the extension textbook includes all of the advanced chapters in it already. So it's enough to buy the extension book if they're an extension student. The extension chapters are carefully labelled with a tag, as you can see there, extension, so that it's quite easy to do your programming and figure out what the topics are that are extension. Next slide, please. It's helpful if you have students who are attending your regular advanced classes and perhaps completing the extension content outside the regular timetable to take time to figure out how you're going to program that. So having a look at the extension chapters down there on the right, I noticed certain things had to be taught in certain orders. The authors have put the orders together as you might in a ideal world, that you can teach things as you want to. The harder topics later in the piece, the topics that require earlier ideas later, and so on. But just mentioning a couple of things. Obviously, the further graphs you have to do after you've done basic graphs. But as William has already alluded to, the polynomials doesn't require a lot of other information. It doesn't require differentiation. That would be an extension topic that you could well do early on in the piece if you were looking for something to slot into your program for students working outside the timetable on their extension work. The further graphs is actually much more accessible than it used to be with the removal of content, as William has talked about. And so that could be an early assessment for an extension student, whereas in the current syllabus, I think many of us have found that if you put it early in your assessment program, it's a bit of a death knell to extension students, as they find that extremely difficult. The combinatorics is obviously late because it's just a difficult topic, and it does require a little bit of probability, but the binomial theorem could be placed early on. Trigonometry, further trigonometry could possibly be a bit earlier, except it's got to be after the trigonometry chapter. Next slide, please. The new extension textbook is about 10% shorter than the old one, which is good news for those who thought the book was a little bit long, probably myself included. But the authors have considered where particular ideas are needed for later studies in extension 1 or 2, and slotted those in as they felt they're necessary. But by and large, it's sort of pretty obvious when things are included, as they should be true to the syllabus. Those who are using the exercises should be aware that basically to come up with the extension exercises, we start with the advanced exercises, and sometimes we adjust the order a little bit. Occasionally we add 1 or 2 extra questions, so the numbers may not be identical. On the right, you can see some section taken from the advanced book and the corresponding exercise in the extension. Question 11 at the top corresponds to question 16 in the extension book, because it's just basic stuff that's certainly in the syllabus, in the advanced syllabus. Whereas the challenge questions there in the advanced are very procedural. They're suitable for an advanced student, but they're probably a bit easy for a challenge student, challenge material for the extension student. The enrichment question that we put, the corresponding to the challenge, and the extension requires stronger algebraic fluency. So all the questions are there in the advanced are also in the extension, but there were some harder questions, harder material that might be expected to be handled by an extension student. And of course, as I mentioned before, theory is sometimes developed more fully in the extension textbook. That is the other difference. And that's it from me.
Okay, thank you very much, Brian and William. And thank you everybody for attending tonight and sticking with us. We're just about on the hour now for the presentation. So we'll spend a little bit now doing a Q&A. So just a reminder, if you have any questions at all, just put them in the chat and we'll get through as many as we can in the remaining time. And then also any questions that we can't get to tonight, we'll also be reaching out via email and responding to any of those questions. And we'll send out a big FAQ to everybody who registered for this, which will also include a recording of this webinar as well as the presentation itself. Okay, so starting off, maybe a question for you, Brian. What do the exercise levels mean in terms of performance? So should a band 6 student be doing all the challenge questions?
If we're talking the advanced or the extension, it may make a little difference, but looking at the advanced book, I think a student could quite happily get a band 6 without doing all the challenge questions or even the end of the development. If they are aiming to be a strong band 6 student, then I think they should be looking at getting certainly to the very end of the development into the challenge questions.
Yeah, thank you very much. Okay, so this is another question that's come from a few people. So given the differences in the extension and advanced book, how would you recommend teachers use the extension 1 book in a mixed ability classroom? So if they don't have a classroom that's all advanced and a separate classroom that's all extension, how do they use the textbooks in a class that's mixed?
Well, obviously, the extension book does include all the advanced questions. So it just means a little bit of logistics of when you're setting questions, making sure that if you want to set the corresponding questions, so students are doing the same questions, that you look in advance and say, okay, I'm setting these questions, and that's the corresponding questions in the advanced book are these questions here. But the differences normally come in the mid-development. So if you're setting foundation questions, early development questions, generally the numbers are the same. Yeah, so the questions are certainly all there, just requires you looking a little bit carefully and seeing if you particularly wanted to set a question, what is that question for the corresponding book?
Yeah, thank you very much. Okay, so this is another question coming from Deborah. So maybe for you, William, or actually for you, Brian. So for the quite new content in Extension 1, such as the central limit theory, have you put in more of an explanation to help teachers get their head around it?
Well, the short answer is the central limit theorem is year 12, and we haven't written that content yet, but we obviously will put an explanation. It's a little bit of a shame in some ways that the normal approximation came out of the syllabus because that was the perfect concrete example of the central limit theorem. I'm expecting that when we get around to writing that content, it'll be a little bit hand-wavy, and understanding the idea behind the fact that the central limit theorem tells you the normal distribution is very important because so much material data you get in life tends to be normally distributed rather than anything more complicated than that.
Yeah. Okay, thank you very much. Okay, maybe to give Brian a break, a question for you, William. What are your suggestions for running assessment in advanced and extension 1 for year 11, and what topics would you recommend? So yeah, what kind of assessment does the syllabus recommend, and what topics would you recommend?
So for year 11, it's probably easier to talk about extension 1 first because you've probably got fewer options. As Brian alluded to, your first assessment, polynomials is a good one. And also the further graphing material is actually much more accessible than it used to be. So you've probably got some choices there. In a typical school, you've probably got one assessment per term. So I think you could do polynomials in one term and maybe the further graphing in another. The order doesn't really matter that much. And then some of those juicier topics like binomial theorem and further trig and that kind of thing may be there in your kind of larger exam if you have that in our term 3 for year 11. For advanced, it's the way the textbook is structured, you probably want to be getting on top of the review pretty early on. As Brian said, if your class is capable, you don't want to spend all of term 1 reviewing stage 5 content. So from that sense, you probably want to be looking at chapters 1 to 5, possibly for a term 1 assessment, with the goal really being to get stuck into that differentiation as early as you can. As Brian said, they are the calculus-based courses. In my opinion, once you've got those key skills, you want to be getting into the calculus. In an ideal world, a term 2 assessment would have introduction to differentiation into it, because as you know, a lot of people that pick advanced aren't quite sure if advanced is the right course for them. If they've gone through all this content and they've never done differentiation, it might not be obvious to them that maybe advanced isn't the right course until they get there later on. So that term 2 assessment on differentiation would be ideal in my experience anyway.
Okay, thank you very much. Okay, so maybe an open question. This is from a few people. Well, so in the case of a student dropping from extension 1 to advanced, Brian, you talked a bit about the differences between the extension 1 and the advanced books. Do you think it's still possible for an advanced student to work from the extension 1 book? So this is, yeah, you might have a student that drops down. Could they continue using the extension 1 book, or would they have to buy the advanced book as well?
Well, they could. And obviously, if money is no object, then which it always is in the real world, then buying the advanced textbook makes it easier to follow exactly what the teacher's doing. When the teacher says turn to page 42 and the teacher says, do question 5, then they're on the same page. They know exactly what you're talking about. But all the content is there. it is perfectly possible to work from the extension textbook, or on-sell it to somebody else and pick up an advanced textbook cheap somewhere. There are often options on the second-hand market. I don't know if I'm allowed to say that on a Cambridge webinar, but there you are.
That's right, actually, and I will just add to that too. So that was a question from Gabrielle. We'll also have so it's common also support material online. So those foundation level skill sheets, those extra quiz questions, the test bank questions, all that material is common between those. So even if a student does drop from extension 1 to advanced, they're still going to have a wealth of resources that they can use to support. That is still going to be also common to advanced. So there's a lot of support there for those kind of students as well, particularly at that lower level if they need it, and into development to kind of build them up. Okay, that looks like just about it, almost. Looks like one more question, possibly, unless someone comes in with another one. So yeah, I think this goes back to you, Brian, again about the questions in the book and the size of the exercises. So how do you, given how long they are, how do you suggest students work through the exercises? So like assigning questions to students, what's your philosophy for kind of assigning foundation versus development at home and in the classroom?
Yeah, well, I mean, obviously, when you first meet an exercise, that's the teacher's call. The teacher's in charge of the classroom. The teacher knows their students. The teacher assigns the exercises they think are most appropriate. So I wouldn't be skipping through all of the foundation questions. I wouldn't start with the development. I think the foundation skills are very important. And it depends a little bit if you've got a class that's graded, if you know they're all pretty capable, and you spend, you could give them a few questions in the foundation and quickly send them a number of questions in the development. Perhaps, however, you have a class which has got quite a range within the class, and I know many schools will be in that situation where there's a range of skills in the class. And then it really does come to differentiated learning. There's no other way around it. You have to sort of know that little Jack who sits at the front and Sally on the right, they need a lot more of the easy questions, and they're a bit slower working. They're not going to get far, and you'll need to talk to them individually, or even have, 3 different little handouts. Here's the questions assigned, and you give each person, okay, you're doing the pink slip, you're doing the red slip, you're doing the brown slip, and on that you've sort of said assign the questions that you know is appropriate for those level of students, to get them through the course that you want to do.
Yeah. Okay. Thank you very much, Brian. Okay. One more quick question for you, William. So Scott says sometimes we found that examples didn't contain all the steps in extension 1 in particular, and there were some gaps in the working. Has this been addressed in the new books?
Yes, it has. So we've gone through and we've looked at all the worked examples, and basically seen sometimes there's a non-obvious but very efficient technique that's been used, and in situations like that, they've kind of been rewritten to maybe, take a bit more of an obvious approach to get to the same end result without some, wonderful technique that gets you there in 2 lines that no one would ever spot. So yeah, that definitely has been thought about and addressed. It's also worth mentioning the videos of the worked examples obviously flesh things out as well if someone's actually explaining what's going on there.
Awesome. Thank you very much. Okay, I think with 15 to the hour, I think that just about does us on time. Thank you, everybody, for attending. And if you have any more questions, keep putting them in the chat and we'll get back to you via email. So passing to you now, Caroline. Thank you.
Great. Well, thank you, Brian, William, and Ben. That was a really great presentation, and I'm sure everyone got a lot from that moving forward with these new courses for next year. So on the screen, just quickly before we finish, we have our 3 Year 11 textbooks there. So all 3 of these will be available in October. The sales team currently do have samples. So we are at the moment visiting schools, doing demonstrations, showing the textbooks and the features that all the gentlemen today have spoken about. So next slide will show you the Year 12 covers. So we will have the 2 standard books, advanced, and then 2 extension as well. So we will have samples for these early next year. So as soon as we have anything that we can share with you, we will definitely be in touch. Next slide. So a lot of these were sort of talked about during the presentation, but we do have a lot of online material for teachers and students. So Ben covered all the chapter review activities, the foundation level skill sheets, chapter tests, and all that good stuff that's very useful for you as teachers. But we will also have an exam generator tool coming for year 12. So this is basically where you can handpick NESA style questions and build your own practice exam for students. So you can print that out, and it is a written exam. So that will be coming soon, as well as all the other features that we do have on our 7 to 10 that everyone loves, the task manager, reporting tools, etc. So all of this, we can actually come out to the school and do a bit of a demonstration as to how this works. And run through it with you, as well as the sample pages of the books. And then the next slide, you will see the New South Wales sales team. So myself, Corinne, Caitlin, and Deborah. So we cover the whole of New South Wales. So we will be in touch with everyone today afterwards with the recording and also the opportunity for us to come and visit you. So on behalf of all of us here at Cambridge, I really hope you enjoyed tonight's presentation, and thank you for sticking around, and we will see you next time. Thank you.